السلام ورحمة الله.
حياكم الله جميعا. Welcome to E21. So today's lecture will be just solving problems in chapter 8. And inshallah tomorrow we'll solve problems in chapter 9. Let's wait for a few more seconds before we start. أدران؟
دكتور كم سؤال تقريبا بنحل؟
We're going to solve 5 questions inshallah. طيب. بسم الله الرحمن الرحيم. Let's start with this question. This one was taken from an old exam, and this question is asking you to there was a switch, and the switch was originally at position A here. Then at t equals to 0, the switch moves to position B. And the first thing that you've been asked about is what is di by dt, the initial value and the derivative of the current. So remember here, you're trying to do the following. So when you're asked about this question, you're been asked about what is the initial voltage across the inductor divided by the inductors. So in order to do that, we need to actually, first we need to solve the circuit and see what's going on. So let's analyze the circuit for t less than 0. For t less than 0, the switch is at position A. So the initial voltage across the capacitor so we have inductor 1 Henry, and this will behave like a short circuit. We have a 1 ohm resistor, and we have a capacitor here, and again here we have a 4 ohm resistor. So if I ask you what is Vt here for t less than 0, you'll see that Vt is actually what is going to be 4 multiplied by 40, multiplied by 10, and it's going to be 40 volts. The initial current for the inductor, meaning this one, it's 0. The reason for that is there is an open circuit here, so the current cannot flow. It cannot flow here. So let's study what happens when when the switch moves to position B. So when the switch moves to position B, what we have is the following circuit. We have 3 ohm, okay, here's 6 ohm. So let's consider the case what happens at t equals to 0 plus, just immediately after closing the after moving the switch to position B. So in order to find, remember here we asked to find di by dt, which is exactly similar to finding the voltage across the inductor divided by the inductance. We know the inductance is half. The voltage passing through the inductor is the one that we're trying to find. So let's apply KVL here in this loop. So if we apply KVL in this loop, we see that we're going to get minus the voltage across the capacitor equals to 0, plus the voltage across the inductor T equals to 0, plus the voltage across the resistor equals to 0. We all agree on this, right? So now let's see what is this quantity here. Remember, we have a capacitor, so the voltage across the capacitor cannot change instantaneously. So if we go back here, we see that this is V0. So this one is 40. And we don't know what's the value of this quantity. So what is the voltage across the resistor here? What do you think, Shabab? What is the current passing through the inductor here at t equals to 0 plus?
0.
0, exactly. So the current is 0. So in this case, I mean, we can think about the entire part of the circuit here as not being connected to the remaining part here. So if this part is removed and I ask you to find the voltage across the 3 ohm resistor, you will see that VR is going to be by voltage divider law, 3 divided by 9 multiplied by 18, which is 6 volts. So this is going to give you 0, and the voltage across the inductor in this case is 34 volts. Now remember, our goal was to find di0 by dt, which happens to be the voltage across the inductor divided by the inductance, which is the inductance in this case is half. So 34 divided by half. And this is going to give you 68. And it's going to be amperes per second. Salman?
Doctor, I didn't understand. How did you find VR?
Okay, if you have a circuit like this, and I'm asking you to find what's the voltage here.
By divider law, but it is connected to the inductor and the capacitor.
Okay, but there is no current flowing here.
If there is no current, we imagine
Yes.
that it is not
Yes,
exist.
it's as if it's not connected.
Okay.
Okay, Hadi.
Doctor, I use source transformation to make it all the circuit in series, and then use KVL, and I got minus 34.
You use source transformation?
Yes.
Okay, if you use source transformation, you will end up with the same thing.
I got the same answer, but with the minus sign.
Then you're making a mistake here. Maybe you're considering VR as... Oh, okay. In this case, maybe you're starting with this one, you're assuming this one is positive, and this one is negative. Nasser, question?
Why the current through the 3 ohm resistor is 0?
The current no, it's not 0. The
So
current here is 0. The current here is 0.
Oh,
Because this is the current across the this is the current across the inductor, and the current across the inductor cannot change instantaneously. So it was 0 when the switch was at position A. Then when we move to position B, the current stays 0.
okay, thank you.
Okay, very good. So now let's see what happens, what type of response we have. Will it be overdamped, underdamped, critically damped, or none of the above? So in order to do that, you may need to actually do, well, sometimes you will not be able to realize it. So in this case, you might need to apply source transformation. So if you apply source transformation, let me add an extra page. If you apply source transformation, remember, you used to have a voltage source in series with a resistor, so now you're going to have a current source in parallel with the resistor. So the value of the current source is going to be 3 amperes, and you have 6 and 3 in parallel. So in this case, you will have a series RLC circuit, L, C. So 3 in parallel with 6 is going to be 2. Okay, so now you have a series RLC circuit. So in order to find the type of response, you need to find alpha. Alpha is going to be R divided by 2L. So R in this case is 2 divided by 2L. L is 1/2. So 1/2 multiplied by 2 is 1. So R is 2 radians per second. Omega naught is 1 over square root of L multiplied by C. L is 1/2. C is 1 over 8. So you will have 1 over 16. And this gonna give you 4 radians per second. So since alpha is less than omega naught, the response is underdamped. And that's the solution. عبد الله أبدأ إله.
اي دكتور ما كان يمديك بس تشيل السورس خلاص تطلع الار equivalent.
Yes, you can do that. You can do that. But in this case, you may need to take the parallel combination of 3 and 6. So you cannot just
إذا
say
شلت
3.
السورس يصيرون 3 parallel.
What's that?
إذا شلت السورس ال 18 فولت بيصيرون 3 و 6 ohms resist in parallel.
Yes. طيب. Okay, let's try to solve this problem here. And in this problem, we're trying to find, in the following circuit, we're trying to find the expression for the current for all times. When you have a question that's asking you about the expression for quantity for all time, you need to consider what happens for t less than 0 as well. So the standard way of solving such a problem is to subdivide it into different subproblems. Here we have 2 scenarios. One when the switch is closed, which is the case for t less than 0. The other one is when the switch is open, which is the case for t greater than 0. So let's start with the first case. Let's start with t less than 0. For t less than 0, the switch is closed. And we assume that the switch is closed for a long time, so the inductor will behave like a short circuit, and the capacitors will behave like an open circuit. The response we are interested in is the current through the inductor. So in order to find the current, you may need actually to first finding the voltage. There are 2 options. The first one is you can either find the current directly, and the second option is you can actually, and it will be much easier if you find the, or let me see, what option did I use? The first option is you can find the current directly, and the second option is you want to find, or you need to find the voltage across the inductor. Then you take the derivative, the voltage across the capacitor. You take the derivative of the voltage, and you will get the current. But let's find the current directly. So let's study what happens for t less than 0. So remember, for t greater than 0, let me draw it here. So this is a circuit for t greater than 0. So the current passing through the inductor, the capacitor here, this is I of t, is this current, right? Correct, Shabab?
Yes.
Okay.
Yes.
So it's the current passing through the is the current passing through an inductor as well. So what do we know about the current passing through the inductor? It cannot change instantaneously. Therefore, here we need to find the current passing through the inductor for t less than 0 as well. So the current passing through the inductor here for t less than 0 is this one, which is minus I of t. This is the negative of the current that we are interested in. So I of t will be minus 100 divided by 10 plus 15, and this is going to be minus 4 amperes. And this is equal to the current 0 plus current the voltage across the capacitor is going to be simply 4 multiplied by 15, and this is going to be 60 volts. So, is it clear what we did here, Ali?
What's the direction for the inductor? The current for the inductor.
So the current through the inductor is flowing this way.
Yes. So why you put it opposite direction and
Because
here?
because I'm sorry, the current passing through the inductor is this way, this direction. So the reason for using negative is according to the passive sign convention, the voltage and the current or the if the current enters from the the highest potential terminal to the low potential terminal, it's going to be positive, otherwise it's going to be negative. And that's what we have. If I ask you, if I give you this one is 20 volts, and this one is, for example, 10 ohm, and I ask you to find this current, I, what should you do? What's the value of I?
It will be negative.
Sure, right?
Yes.
It's exactly the same. That's exactly what you could do.
But if I put it positive, is it okay if I put it?
No, it's not okay. Why?
Isn't the current flowing from the 100 volt to all circuit from the right?
What we are interested in here, Ali, is to, I mean, don't think about it this way. Think about it as the current passing through the inductor. So what you want to do is you want to ensure that the current passing through the inductor is, first of all, there is an assumption in the direction of the current. So assuming that we're interested in the current is flowing in this direction. So what we want to do, we want to make sure that when we move the switch when we open the switch, the current here is continuous. The current is only continuous if it's flowing this direction. واضحة؟
Okay.
أحمد؟
دكتور الحين بالأساس الحين مو مفترض أن تكون هذه الدائرة ديد سيركت.
ديد سيركت؟
يس.
كيف ديد سيركت؟
يعني أقصد أنه ما في sources.
For t greater than 0?
Yes.
Of course it's going to be eventually 0. That's all the natural response circuits that we studied so far. Eventually it will be 0. But we're interested in what happens at very short few seconds or few milliseconds after you open or close the switch. That's exactly what we've been doing. Well, here is quite different circuit. But if you go to any of the natural response circuits that we've studied, you will see that eventually it will be 0. That's why we have e to the power negative something.
شكرا.
Okay, this is the current. And for t greater than 0, again, I'm drawing the circuit. So now I need to find what type of response that I have. First of all, I will note here that I have a series RLC circuit. So this implies that alpha is going to be R divided by 2L. And in this case, alpha is 5 radians per second. Omega naught is 1 over square root of LC. And if I do the calculation, I will get 4 radians per second. So clearly, alpha is greater than omega naught. So I have over damped response. So the final value of the current, or if I study over damped response, I will see that the value that I'm interested in should be the final value. So I don't need to differentiate between a natural or step response. I can just use the general formula. And what's the final value of the current? I have no source, so the final value of the current will be 0. And this is why we call it the natural response. And the circuit, of course, will be dead. So now what I need to do, I need to find S1 and S2. I know for overdamped, S1 is minus alpha plus alpha square minus omega naught square. S2 is minus alpha minus alpha naught square minus omega naught square. So if I do the calculations, I will get minus 5 plus 3, and this is going to give me minus 2 radians per second. This one I'm going to get minus 5 minus 3, and this is going to give you me minus 8 radians per second. Okay. So I can write I of t as A1 prime E minus 2t plus A2 prime E minus 8t. So now I need to find the coefficients, A1 and A2. In order to find the coefficients, I need to substitute the initial conditions here. So what is the initial value of the current? Clearly, the initial value of the current is minus 4. And this is the first equation. The second equation, I need to find the derivative of the current with respect to time. And this is going to be minus 2 1a prime minus 8 a2 prime. So what is this current? Is going to be VL divided by L. So what is VL here? What is the initial voltage, or what is the voltage across the inductor immediately after the switch is open? So in order to do that, I need to apply KVL. So if I apply KVL here, I know that the voltage V0, or the voltage across the capacitor immediately after the switch is open, is going to be continuous, meaning that it's going to be equal to 60 volts. I know the current passing through the resistor is going to be continuous, because here the current passing through the resistor is the same as the current passing through the inductor. So in this case, I can find, I can apply KVL. So apply KVL, I will get so I'm assuming that this is a voltage across the inductor. And I'm applying KVL here, this way. So I know this one is 60. This one is going to be I0 prime is going to be negative. And it's going to be negative 60. So this implies that the initial value of the current, or the initial value of the voltage across the inductor is 0 volts. Therefore, and this is the second equation. So I have two equations, two unknowns. So if I solve for them, I will get A1 prime to be minus 16 divided by 3 volt, not volt, amperes. A2 prime is going to be 4 divided by 3 amperes. Then I of t is going to be minus 16 divided by 3. Okay, any questions, Shabab? You see, both of the problems that we solved here, they're not straightforward. So the main issue here is to analyze the circuit just before the. So once you have big picture, once you correctly analyze the circuit before the switch is open or before the switch is closed, you almost have everything you need to solve the circuit. Dela?
تقدر ترجع للسيركت.
Yes.
إيه سويت الكي في ال، كيف حددت انه كلهم ينجمعون مع بعض؟
كيف؟
الريزستور والفولتج حق الدكتور والفولتج حق الكاباسيتور.
So we're applying KVL for t equals to 0 plus.
الحين الفولتج حق الاندكتور والفولتج حق الكاباسيتور مو عكس بعض.
Why? There is a resistor between them. There is a 15 ohm resistor between them.
فيصيرون يعني نفس الاتجاه.
This is the loop that we're trying to apply KVL at. If you're saying they're equals, means that there is no current flowing through the resistor.
لا مو equal، قصدي التيرمينالز. التيرمينال حق
According to the
الاندكتور.
passive sign convention, this is the direction of the voltage, because the current flowing this way, and this is the direction of the voltage across the inductor.
اوكي.
The third question that we want to solve is this question, and this question is taken from your textbook. And in this question, we are asked to find the current passing through the inductor for t greater than 0. What happens here is we have two switches, switch 1 and switch 2. So for t less than 0, switch 1 was open, switch 2 was closed, meaning that the 10 ampere source is feeding your circuit for t less than 0, or feeding the inductor. For t greater than 0, the inductor is fed by the 80 volt source. So let's see what happens. We're asked to find the current passing through the inductor, IL of t. So let's see what happens for t less than 0. Let's draw the circuit for t less than 0. So we have two separate circuits. Abdulaziz?
So the resistor will be cancelled because it's short-circuited, and IL will equal to an ampere.
Yes, exactly. So the current passing through the inductor here is going to be ten amperes. The voltage passing through the voltage across the capacitor is going to be again, I need to find the voltage across the capacitor because I'm going to use it to find the initial conditions here. Okay, from t less than 0, I found the initial conditions. So let's study the circuit for t greater than 0. For t greater than 0, this part is removed. So I have 10 ohm, another 10 ohm, 80 volt, 250 microfarad, and 16 millihenry inductor. So what I will do is this one resembles a parallel RLC circuit. So what I will do is I will use source transformation to make sure that everything is in the right. Everything looks in parallel. Again, I don't need to use source transformation, but I'm going to use it to ensure, or to make things visually easier to me. So I have 80 volts in series with 10 ohm resistor. So 80 divided by 10 is 8. So the current is going to be 8 ampere. Then I will have 10 ohm resistor. This one is going to be in parallel with 10 ohm resistor. This one. So the parallel combination will be 5. So I will have the following circuit. Okay. Again, I'm interested in finding this current, the current passing through the inductor, IL of t. So what is IL of t for as t approaches infinity. Again, as t approaches infinity, the capacitor will behave like an open circuit, the inductor will behave like a short circuit. So you'll have a short circuit in parallel with 5 ohm resistor and in parallel with the current source. So the equivalent resistance will be 0. So all of the current will flow in the short circuit. The final value will be 8 amperes. Okay. Now I know the final value. I know the initial values. So I need to know what type of response that I have here. From the type of response, I can construct the general solution. So it's a parallel RC circuit. So let's find alpha. Alpha is 1/2 RC. And if I do the calculation, I'm going to get 400 radians per second. Omega naught is 1/square root of LC. If I do the calculation, I'm going to get 500 radians per second. So clearly, omega naught is greater than alpha. So this implies that the response that I have is going to be under damped. So for underdamped response, the current, the general form of the solution will be the final value plus so what's missing here, I know alpha. What's missing here is the coefficients B1 prime and B2 prime, and I'm missing omega d. So omega d is the damped or the damped radian frequency is going to be omega naught square minus alpha square, and this is going to be 300 radians per second. So now let me find the coefficients. So IL of 0 is going to be I final plus P1 prime. And from the initial conditions, the initial value of the current was 10 ampere. And the final value was 8. So P1 prime is going to be 2 amperes. Now I want to find the derivative of the current with respect to time, and this derivative is evaluated at t equals to 0. And again, this derivative of the current is equivalent to or is equal to the value of the capacitor voltage of the inductor voltage divided by the inductance. So what is the inductor voltage? Again here, since the inductor is in parallel with a capacitor and the voltage across the capacitor cannot change instantaneously, this implies that the voltage across the inductor is going to be this.
40.
Okay, mute yourself. Okay, the voltage across the capacitor is going to be the initial voltage, which was 40. So 40 divided by 16 millihenry. Okay, so let's apply the initial conditions here. So if you differentiate the expression for the current with respect to time, you will get minus alpha P1 prime, which is the quantity that we found, plus omega d v2 prime. And if you do the calculations, I'm not going to do that. You can use your calculator. You see that it's going to be 11 amperes. So now we found the coefficients, you found everything you need. What's left is to write the full expression. So the full expression for the current is going to be the final value was 8. The unit is ampere, and this is true for t greater than 0. Okay, any questions, Shabab? Okay. So let's try to solve this exercise. And again, this one is taken from the book, and this one is not straightforward exercise. There's a typo here. This one should be. This is V naught.
دكتور يعني الفي نوت اللي على اليمين خطأ.
كيف؟
الفي نوت اللي على اليمين اللي على الاندكتور تعتبر خطأ.
Yes, it's not the V naught that we're interested in.
Oh, okay, thanks.
Because it doesn't make sense to find the voltage across the inductor. Wait, okay. Let's try to solve for this circuit. So we're asked to find the voltage V naught for t greater than 0. In this case, you're asked, or your task is actually to find the initial values first. And the initial values can be analyzed or can be found by analyzing the circuit for t less than 0. So for t less than 0, the switch is closed, and the capacitor will behave like an open circuit. This one will behave, the inductor will behave like a short circuit. Okay. So what do we have? What do we have in here? So what we have in here is we need to find the voltage across the inductor, across the capacitor for t less than 0. So what is V naught in this case? It cannot be 100 volts. It has to be something different. In order to do that, we need to apply KVL. So V naught is going to be minus or plus, it's going to be Hold on a second. So if you apply KVL here, you will get minus 100 plus 20 times the current. We call IA, and this current is going to be IB. So 20 multiplied by IA plus 20 plus 100 multiplied by IB plus V naught equals to 0. So in this case, V naught will be 100 minus 20 IA minus 100 IB. Okay, so what is IA, what is IB? In order to do that, you need to apply the mesh current method. So if you apply the mesh current method, this one is IA, this one is IB. So using mesh current method, you'll see that Ahmed, question.
دكتور الكرنت اللي مار على ال 100 اوم والمفترض يكون مجموع الاي بي والاي اي.
IA is this current, this side. There's no current in this mesh because we have an open circuit.
اوكي تلخبطت. شكرا.
Okay, this is the first circuit, the first mesh current. The second one is applying KVL at the upper mesh. So if you apply KVL at the upper mesh, you will get 300 IB plus 100 IB minus IA plus 100 IB equals to 0. So if you do this calculation, you get minus IA plus 500 IB equals to 0. This is the second equation. You have two equations, two unknowns, so you can easily find the current. So IA is going to be 1 amperes. IB is 0.2 amperes. So now you go back and substitute. You'll see that this one is skeleton. Going to be negative 100, 20 multiplied by 1, plus 100 multiplied by 0.2, and the result will be negative 100 plus 40, 60 volts, negative 60 volts. So the initial value of the voltage across the inductor is, or the capacitor, is going to be negative 60 volts. So now let's draw the circuit for t less than, for t greater than 0. For t greater than 0, the switch is open. So what we have in here is this part can be removed from the circuit because there is no current flowing in this part. So the circuit will look a lot like this. So I jumped one step ahead, so let me put this one is 31.25 microfarads. You get 80 ohm. Then you get 300. And here, I think 100 and 100 and 100. Okay, so in this case, we have a series RLC circuit. We know the value of the fault. We know the value of, with all of the values that we have. So we need first to determine what type of response we have. Was it or is it overdamped, underdamped, or critically damped? And let's find alpha first. And from alpha, we can deduce the type of alpha and omega naught. From alpha and omega naught, we can deduce the type of response that we have. Okay, so we have R divided by 2L. This is going to give you 500 radians per second. Omega naught is going to be 1 over square root of LC. And this is going to be 400 radians per second. So clearly, alpha is greater than omega naught. So we have overdamped response. So the solution for this one is going to be V final and clearly, since we have no source for t greater than 0, so V final is going to be 0. So this is the natural response. So what is S1 and S2? Maybe at this stage, you know, if you have 500 and 400, the remaining quantity is going to be 300. So it's going to be minus alpha therefore S1 is going to be minus 200 radians per second. S2 is going to be minus 800 radians per second. So now we found S1 and S2. All what you need to do is to find actually A1 prime and A2 prime. So you can do that by applying the initial conditions. So the initial value of the voltage, we found it to be negative 60 volts. Now the initial value of the derivative of the voltage, again, this one should be related to the current passing through the capacitor. So the current passing through the capacitor, so this is the voltage across the capacitor. And the current that we know is the current passing through the inductor. And the current passing through the inductor from for t less than 0, it was flowing in this direction. So we know from the initial conditions here that the initial value of the current is going to be IA, because this is the same as the mesh current IA. So the initial value of the current across the inductor is going to be IA, which is 1 ampere, But according to the passive sign convention, the current passing through the capacitor, in order to have, according to the passive sign convention, the current passing through the capacitor should be flowing in this direction. So the relation between IC of t and I of t is going to be IC of t is equals to negative I of t. So in this case, we have Is it clear, شباب, why we have a negative current?
ممكن تعيدها دكتور؟
What's that?
ممكن تعيدها إذا ما عليك أمر.
طيب. So I want to draw it this way. If I have a capacitor, if I have an inductor, then the voltage across the inductor is L EIL by dt. This is true if the current is flowing in this direction. If instead of that, the current is, according to the passive sign convention, if the current is flowing in that direction, then VL will be minus L EIL by dt. Do you agree with me on this?
Yes, I agree.
Okay. Similarly, if we have a capacitor, so the capacitor IC will be C dVc by dt. If the current is flowing in this direction, if the current is flowing in the other direction, you will get Do you agree with me on this?
Yes.
Now let's go back to the circuit we have. So the initial value, or the current, the things that are fixed are the current passing through the inductor for t equals to 0, and the voltage across the capacitor for t greater than for t equals to 0. So we know the voltage from the initial condition is going to be negative 60, and it's going to be in this direction. This is the direction of the voltage that we're interested in. So we're assuming that the positive terminal is connected this way, the negative terminal is connected that way. So according to the passive sign convention, in order to have a positive current, you have to have a current that's flowing from the positive to the negative, صح?
صح.
So this current that's flowing from the positive to the negative is going to be equal to the negative of the current passing through the inductor. Okay?
Okay.
Clear.
Okay, that's why we have a negative here. So if we solve, we get A1 prime equals to 256 divided by 3. A2 prime is 76 divided by 3. And if we write the solution, it will be Okay. Any question, Shiva?
Doctor,
Yes.
what if we applied KCL on the node that's between that's under the IC in the corner, in the left corner at the
Here?
bottom? Yes, yes.
If
We
you-
will get the
Yeah.
same.
Yeah, if you apply it, you'll get IC. IC is IC plus IL equals to 0 because they are both entering the node. So this
Yes.
implies that IC equals to negative IL.
So it's the same thing, right?
Yes, it's exactly the same thing.
Okay, thank you.
Okay, the last question that I want to solve is pretty straightforward. It's not that complicated. And this question is we are the only interesting part, or the interesting part here, is throughout the course we solve two problems. One is you will have a source before the for t less than 0, and then the source is removed, or the other way around. But in this case, what we're going to do, we have the same source, but for t less than 0, the value of the source is 200 volts, and for t greater than 0, we will not have a switch. The only thing that we're going to do is we're going to adjust the value of the voltage source to 150 volts. So what we are asked to do is we're asked to find V naught of t. So let's first draw it for t less than 0. For t less than 0, the voltage across the capacitor will behave like a short open circuit. And the initial value of the voltage is going to be what? $100 volts. The initial value of the current passing through the inductor is going to be 0, because it's a series with an open circuit. So this one is 200 volts. Now for t greater than 0, what we have in here is the following. We have 150 volts. So the value of the voltage source has changed to 150. 25, 250, so again, here we have a series RC circuit. The final value of the voltage is going to be what? It's going to be 150 volts. So we have a series RC circuit. So let's determine the type of response we have by finding alpha and omega naught. So alpha is going to be 50 radians per second. Omega naught is going to be 1 over square root of LC, and this is going to be 40 radians per second. So alpha is greater than omega naught. Abdullah?
Doctor, I think the V naught initial is 200.
This is not the initial value. This is a t equals to infinity. This is the final value.
I'm sorry.
Good. Okay, so alpha greater than omega naught. So this implies that we have over the response. So V naught of T alpha is actually 50. Okay, so we have this one negative 20 is 2 is negative 80. So we can easily solve for the initial or for the final. We can solve. We can find the coefficients by solving the initial conditions. In this case, this was 200. 200 will be A1 prime plus A2 prime. B Okay, so now what is the initial value of the current through the capacitor? Since the capacitor and inductor, they are in series, so they must have the same current. And since the initial value of the current passing through the inductor, cannot change instantaneously. So this implies that the initial value of the current passing through the inductor is passing through the capacitor is also 0. Two equations, two unknowns, so I can easily solve. Okay, now I found the coefficients. So all what you need to do now is substitute. So if I substitute, I will end up with 150 plus 66 Okay, that's all. Any questions, Shabab? Ahmed?
الدكتور ممكن تشرح من البداية كيف السويتش مو موجود، يعني كيف تحته قبل وبعد؟
Okay, before this, the value of the voltage source is 200 volts. This is what happens for t less than 0. Then at t equals to 0, you change the value of the voltage source to 150. So there is a change. The change took place not by a switch, but by changing the value. So think about it this way. You have 200 volts. You have 150 volts. And This is A. This is B. This is what happens. You can think about it this way.
السويتش صاير بينهم لأنهم هم المتغيرين صح؟
كيف؟
السويتش صاير بينهم لأنهم هم المتغيرين.
Yes, what happens for t less than 0, the switch or the value of the voltage source. So what we are studying here, we're studying the abrupt change in the circuit. So this could take place because we have switch or because we're changing the value.
يعطيك العافية دكتور.
عدنان؟
دكتور وين الاقي الاسئله هذه؟ هل هي مرفوعه على البلاك بورد؟
I will upload it to Blackboard.
Okay.
I did that for the previous one. You see them in the extra resources under problem sessions. Okay. Any other question, شباب؟ مهند؟
بس حبيت الدكتور أسأل عن الأوراق حقت المتيرم. هل
Yes.
أقدر أمر بكرة أخذها ولا؟
Let me double check if I'm in the office. Okay, will you be in the? Okay, any other technical questions? So I need to start recording. I will come back to you. ناصر؟ ناصر؟
دكتور على آخر كوز ما أمداني إن أرفع الكوز على
You know the rules. If you don't upload it, you will get a 0.